Hi everyone, today I am going to explain how ray diagram can be drawn. Today my topic is image formation by convex lens. So to know how to draw image, we should know some rays that is used to draw ray diagram. Rule number 1. So this is your convex lens. Midpoint is optical center. This is your focus. This is center of curvature. Center of curvature or twice it. So similarly, this side will be one focus, F1. This is center of curvature. So rule number 1: if a ray coming parallel to the principal axis after refraction passing through focus. Rule number 2: if a ray passing through F, if a ray passing through F after refraction, if a ray passing through F after refraction, it becomes parallel. So rule number 3: if a ray passing through O, it will remain undeviated. So out of these 3 ray, we are going to take any 2 rule to draw ray diagram to show how image is formed by convex lens. So we have different cases, so we are going to draw one by one. So case 1, when object is at infinity, Say, to draw ray diagram, I request you all to take a sharp pencil and just give the marks once at a time. Don't rub it many more times. And this lens should not be too thick. It should be a thin lens. So midpoint is optical center. So there are 2 surfaces. This is one surface. This will be another surface. Accordingly, you locate C. Means center of curvature. So half of center of curvature, it will be of this midpoint of radius of curvature, there will be focus. Say according to first case, the object is lying at infinity. We already know the light rays coming from far object is always considered to be parallel. So according to that, suppose one ray is coming and passing through O, then it will remain undeviated. Say another ray I am going to draw. This one, these 2 rays are parallel because rays are coming from distant object, and after refraction it becomes parallel. So this refracted ray and this refracted ray meet at this point. Therefore, image is formed at focus. After drawing that, we always should mention what is the nature of the image. Nature will be real and inverted. Why? Because refracted ray actually meet at it. So it will be real and inverted. Position. Where is the image located? It will be at F. What about the size? Size is diminished, smaller than the object. Diminished or smaller than the object. I think it is clear to you. Then we are going to draw that case 2. Say object is at infinity till infinity. Suppose I am keeping the object beyond C. So object is beyond C. Beyond C. Case 2. So for that, let us draw. So this will be a convex lens. Midpoint optical center. So these are the 2 center of curvature. One will be first center of curvature, second center of curvature. Then it will be one focus. This is another focus. Generally we mention focus 1, focus 2, then twice of F2. Same thing you can write as well as you like. Twice of F1. Say now object is lying at beyond C. C or twice. Same thing. So one ray coming parallel to the principal axis. After refraction, it will pass through focus. The second rule, if a ray passing through F after refraction, it becomes parallel. So this refracted ray actually meet at this point. So image will be formed here. So again, Nesar is real and inverted, real and inverted. Then position will be in between C and F, in between C and F, and size will be diminished or smaller than the object. I think it is clear to you. Next, we are going to do that when the object is at C. Object is at C. At C. So for that, again we are going to draw a lens. So this is a lens. Midpoint is optical center. This is principal axis. So when the object is at C, according to one ray coming parallel to the principal axis after reflection passing through focus. Next one ray passing through focus after refraction, it becomes parallel. So this refracted ray actually meet at this point. So where the image will be formed. Again, here nature of the image will be real and inverted, and position will be, it is at C. And what about the size? Size will be same as the object. Same as the object. So is it clear, my dears? So to get proper image, try to locate the C appropriately, and locate C. Similarly, try to locate C even for the another surface, and this midpoint will be considered as a focus, and this distance, similarly for this side, this distance and this distance will be equal. Once you locate the point appropriately, your ray diagrams will be coming to be a perfect one. That next, it will be in between of next case, it is when the object is in between C and F. I forgot to mention the numbers. Please note down your number accordingly. Case number 1, 2, 3 like that. So similarly, this one is C, one more C. Here focus, this is optical center. Distance should be appropriate. Then again, now I am keeping in between C and F. One ray coming parallel to the principal axis, after refraction it will pass through focus. Next one, that one ray passing through O, it will remain unchanged. Then these two rays meet at this point, so we will get image here. Again, what is the nature of the image? Real and inverted. It will form beyond C, and it is enlarged. Is it clear to you? Next we are going to draw when the object is at F. Object is at F. Focus. So again, see how I can draw the drawing. So this is a lens, midpoint, principal axis, C, midpoint, focus, then object is at focus. One ray coming parallel after reflection passing through F. Next one ray passing through remain unchanged. Now you see, rays should be straight. Draw with scale. I have drawn here without scale, so it should be a straight one. So these two rays are coming to be parallel. These parallel rays, if you are going to draw on this side, they may meet at infinity. Therefore, similarly, laser will be real and inverted, and position will be at infinity. infinity, and size will be enlarged. So that means convex lens can form two types of image. One is real, one is virtual. So whatever drawing we have drawn, these are all for real images. I repeat one more time, when the object is beyond at infinity, next one is at beyond C, next is at C, next one is in between C and F, next one is at F. Now I am going to draw when the object lies between F and O. When the object is in between focus and optical center, F and O. So in this case we are going to have virtual image. See here. So midpoint optical center, this will be one more center of curvature, half focus, this is another focus. Now the rays will be, object will be here, one ray coming parallel, after refraction passing through F, one ray passing through C, remain unchanged. Now this ray and this ray, if we are going to draw on this side, it won't meet. So what we will do, we will produce the rays backward. Once we produce the ray backward, they will appear to meet at this point, appear to meet here. So we will get the image at this point. So if AB is the object, then A dash B dash will be the image. Now here we are going to write what is the nature. Nature is now virtual and erect. Virtual and erect. What is the position? Same side of the object. Same side of the object. What about the size? It is enlarged. So that's all about the ray diagram, how image is formed by convex lens. Now next one we are going to learn image formation by concave lens. Image formation by concave lens. Concave lens. Say like before, first we will see that ray to get image. So this is one concave lens. This will be the midpoint optical center. This will be one surface according to locate C. Similarly for the second surface also we will locate C. And this midpoint of radius of curvature will be focus. Similarly this midpoint will be focus. Say any ray coming parallel to the principal axis, after refraction by the lens, it will appear to diverge from focus. It will appear to come from focus. This is rule number 1. Then next, say this is one concave lens. Similarly like before, it will be the optical center. Second one is if a ray passing towards F. Say this ray is passing towards F, moving towards F, then after refraction it becomes parallel. This will be the second ray of light. Then next one will be the third one. Say one ray, if it will passing through O, remain unchanged. It may goes like that, then also it will remain unchanged. So out of these three, we are going to take any two rays to get image formed by concave lens. Please remember, concave lens can always form virtual, erect and diminished image. So we are going to draw ray diagram for concave lens. This will be the optical center. See, this will be a part of a sphere. Locate C. Accordingly, locate F. Similarly, this will be the another sphere. Lens has two spherical surfaces. So, according to locate F. First focal plane, second focal plane. So, next, any position. So, I am keeping the object here. AB is the object. One ray coming parallel to the principal axis. After refraction, appear to come from focus. Next one, if a ray passing through, remain unchanged. So this refracted ray and this refracted ray appear to meet here. So we will get the image A dash B dash here. So again, like before, we will write what is the nature. Nature is virtual and erect. Virtual and erect image. What about the position? Position will be same side of the object. Same side of the object. Then third one is size. What is about the size? Size will be enlarged, bigger than the object. So this is another important ray diagram. So please practice to draw how to draw ray diagram. So by drawing all those figures, we come to know the concave lens can form virtual erect image of this will be the diminished. Sorry, this one will be diminished. So I repeat one more time. Convex lens can form two types of image, real as well as virtual, and concave lens can form only virtual image, whatever be the position of the object. Then practice this all figures repeatedly because it comes in the exam. So next class I am going to discuss about the lens formula and its application in numericals. Thank you.